Hello everyone, welcome back. My name is Mr. Cobalt, and in this video we're going to go over how to calculate the amount of mercury in a polluted lake. And so with this problem, they're asking for the amount of mercury. So they give us the amount of mercury in a polluted lake in concentration. So they tell us it's 0.4 micrograms per milliliter. And they say that the lake has a surface area of 100 miles squared and an average depth of 20 feet, right? And so when they give you the average depth, that's really important to understand because basically we know that the bottom of a lake is not the same. It's jagged. It's got highs and lows, right? But when you average it out, basically we can say if it's an average of 20 feet, that's like saying that like we could flatten out the bottom of the lake so that it is 20 feet. So that's the average. So we can, and the great thing about an average is that we can now think of the lake as a large cylinder, right? So the area is 100 miles squared. So we could think of that as a circle. We could also think 20 feet deep. So this we can think of the lake as a cylinder. So we can now use the volume of a cylinder to calculate the volume of this lake. And then we can use that to find the amount of mercury in the lake. And so they want to know that in the number of kilograms. So, so we have this is the concentration of the mercury. So notice they're giving us micrograms per milliliter. Whenever they give you a unit per unit conversion factor, you should be thinking conversion factor. So the first thing we want to do is pull out the conversion factors. So first conversion factor is the concentration. So that means 0.4 micrograms per, oops, made a mistake already. Okay, so micrograms of mercury, and I'm going to use Hg for mercury, is going to be equal to 1 milliliter of mercury. 1 milliliter of mercury. So that's our first equality that we're going to use as a conversion factor. And they give us the surface area of the lake, 100 miles squared. We're going to think of this as a circular lake. And we are given an average of 20 feet of depth. Okay, so they want to know how many kilograms of mercury are in this lake. So the question then is, where do we start? Where do we begin? Where do we end? And so we go to the question. So remember, the question almost always is going to give you the ending and the beginning of your problem. Not always, but almost. So the beginning of the question is the end of your problem. How many kilograms of mercury is the beginning of our question? That is where we're going to end. That's our goal. So we want to know how many kilograms of mercury are in this lake. So where do we begin? Well, since they give us the concentration, there's milliliters and micrograms. We're going to have to start with the volume of the lake, but we're going to need to calculate that. So we need the volume of the lake. Once we get the volume of the lake, we can then use our conversion factors to find the kilograms. So they gave us the surface area. So area multiplied by the length of your cylinder. If we're thinking of this as a cylinder, right? If we draw a cylinder here, right? Here's my lake. This is the surface of the lake. And if we were to go down to the depth, so that would be our lake. So this is water, right? So this is water on our lake. And so we're thinking of this as a cylinder. So that's going to be 20 feet deep. And then the surface area here, this area here, they're saying is 100 miles squared, right? So we can use the volume of our sphere, or of a cylinder. So the volume of the cylinder is the surface area, which is pi r squared, which is radius, r is radius, multiplied by the depth here. That's going to be our length or height. So L for length, or you could put H for height. It doesn't matter. We're multiplying by some length. So multiplied by H. So this will be our H, our height of or depth of our lake. So we can now use this to find the volume. So what's the radius? Well, so we get, so here, this would give us our area, right? That's area, right? So we don't need the radius because they gave us the area, the surface area already. So that is what we're going to be given. So area, so the volume area of your cylinder is going to be equal to the area times whatever else you're given, height or length or depth. So that would be the volume of your cylinder. In this case, if it was a circular cylinder, right? Of course, cylinders are circular. Then the area is found by pi times the radius squared. But again, they gave us the surface area, so that we're going to plug in. So if we take our volume, but first, before we get our volume, we got to remember that our concentration is micrograms per milliliter. And so we're gonna need to make sure that our units can convert to milliliters. And so one of the things we want to keep in mind is that 1 centimeter cubed is going to be equal to 1 milliliter. So if we can get our unit in centimeters cubed, then we can use this as a conversion to milliliters. So which means that we're going to have to convert feet to centimeters, and we're going to have to convert miles to centimeters as well. And so that way, when we do our multiplication, we will get centimeters squared to multiply by centimeters is going to give us centimeters cubed. So we're going to have to do some calculations. So here they give us 100 miles squared. So we have 100 miles squared. And we're going to have to do a series of conversion factors to get to centimeters squared. So miles, we know, or we can look up that 1 mile is equal to 5,280 feet. That's true by definition. So we could put 1 mile on the bottom and 5,280 feet on top. Now, notice we have miles squared here and only miles on the bottom. So we need miles squared. So what we can do is either multiply again by the same conversion factor, and then that way we'll have miles times miles on the bottom to get miles squared. But an easier way to do that is just square the whole thing. That way we have whatever's on top is squared, whatever's on the bottom is squared. That means we'll have squared, miles squared, and feet squared on the bottom and top, respectively. Okay, so, and it also saves space. But we're just going to need to remember that when we're doing our calculation, these are squared. So the next thing is, now that we have feet squared on the bottom, so miles and miles squared cancels out. So now that we have feet squared on the top, we're going to have to convert feet to something else. And so since we know that 1 foot is equal to 12 inches, then we could use that to convert to inches. And then we could use 1 inch is equal to 2.54 centimeters to convert to centimeters. So let's do that. So I have feet squared on the top, so I'm going to have to put 1 foot on the bottom, 12 inches on top. again, since I have squared feet up here, I'm going to have to square this to get squared feet on the bottom and squared inches on top. So that way feet squared cancels out. Okay. But I leave the square there because I'm going to have to square the number. The number is squared. So even though feet is canceled out, I still have to square the numbers. All right, now they have inches squared. I'm going to multiply by another conversion factor. The last one, 1 inch is equal to 2.54 centimeters. So the 1 inch goes on the bottom because I have inches squared here, and then 2.54 centimeters on top. And again, I'm going to have to square that so I can get squared inches and squared centimeters. So the inches squared cancel out. And now I have centimeters squared on the top. So now all I need to do is just do my calculation. And so let's calculate the number of centimeters squared. So I'm going to multiply 100 times 5,280. Hold on a second. 100 times 5,280, and I'm going to square that because that's squared, multiplied by 12 squared, multiplied by 2.54 squared, so multiplied by 2.54 squared equals, and then everything on the bottom is 1, so I don't need to really divide by anything. So the answer I get is a really large number. So that's going to be equal to, let's see, 2.589, 2.589 times 10 to the 12. So that's 12 power. So this is centimeters squared. So now I have to also keep in mind the number of sig figs I'm allowed. So I need to remember that when you're multiplying and dividing, the rule is the number of sig figs you're allowed in your answer is the same as the number of the least number of sig figs in the numbers you are multiplying and dividing. So notice here that I have 100. There is no decimal point at the end of the 100. So therefore, there is only one sig fig here. Remember, zeros at the end of your number, farthest to the right, those are your trailing zeros. Those zeros are only significant if you have a decimal point. We don't have a decimal point here, so they are not significant. So that is one sig fig. So we have one sig fig there. This we have, this is true by definition. This is exact, so that's infinite. This is true by definition. That's exact. So therefore, infinite sig figs. This is true by definition. So it's exact. So all of these are exact. So we ignore that. So that means that your answer is only allowed one sig fig. So we can only go up to that number there. We're going to keep the rest because we want to avoid a rounding error. But I underline the 2 to let me know that I'm only allowed that sig fig up to that point there. All right, so I have my area in centimeters squared. Now I have my depth. I need to convert that to centimeters squared, centimeters as well. So I'm going to start with 20 feet over 1. And again, I'm going to use these conversion factors here, these equalities. So I know that 1 foot is equal to 12 inches. Feet are on the bottom because I want to cancel out feet on top here. Now I have inches. And then I do another conversion factor because I want to get centimeters. So 1 inch is on the bottom because I want to cancel out inches. And 2.54 centimeters is on top. So inches cancels out. Now I have centimeters. So now I can calculate the length or depth of my lake in centimeters. So 20 times 12 times 2.54 equals, all the bottom ones are 1, so I don't need to multiply by that or divide by that. So so my answer becomes 609.6 centimeters. And so again, with the significant figures, the answer must have the same number of sig figs as the least number here. Now, again, these are exact. So 12 inches to 1 foot, 2.54 centimeters to 1 inch, those are exact. So they're infinite number of sig figs. So the least number is going to be here. And notice again, there's no decimal point. So that means that 0 at the end is not significant. So that means, again, this is only 1 sig fig. So that means I'm only allowed 1 sig fig. So that digit there in the hundreds place is what I'm allowed. But I'm going to keep the rest because I need to use these numbers in further calculations and I don't want to have a rounding error. Okay, so now I have my depth in centimeters. I have my surface area in centimeters squared. So now I can use this equation to find the volume. So the volume is equal to the area, which is 2.589 times 10 to the 12 centimeters squared, multiplied by the height, which is 609.6 centimeters. And so then all I need to do is calculate that. So I got my 609.6 multiplied by 2.589 times 10 to the 12 equals, and I get a really huge number. So 1.57. So 1.578 times 10 to the 15. And that's going to be centimeters cubed. I have centimeters cubed. And remember, 1 centimeter cubed is equal to 1 milliliter. So that's the same as milliliters. So that's going to be equal to 1.578 times 10 to the 15 milliliters of water in the lake, the lake water. Okay, so, and again, remember that I have 1 sig fig here, 1 sig fig here. So that means in my final answer, I'm only allowed 1 sig fig. So when I get to my final answer, I need to keep track of that. Okay, so now I have the volume of the lake, and they give me the amount of mercury per volume of lake water, per milliliter. So now I can use this to convert from milliliters of lake water to micrograms of the mercury. And then I can convert that to kilograms using my relationships of conversion factors involving the prefixes and prefix multipliers. So you need to know your prefix multipliers if you're going to convert between metric units of the same category. So length to length, volume to volume, things like that. Okay, so I'm going to start with my volume here. So I have 1.578 times 10 to the 15 milliliters of lake water. I'll put LW for lake water. Put that over 1, and now I'm going to use my conversion factor here. So 0.4 micrograms. Oops, I already have it here. So 0.4 micrograms of mercury is equal to 1 milliliter of mercury, or I should say that's not mercury. I made a mistake. Why didn't you guys tell me? So it's a minor mistake. This would be milliliters of lake water, not mercury. My bad. Okay, so So now I have 1 milliliter of lake water is equal to this many micrograms of mercury. So I'm going to put the 1 milliliter of lake water on the bottom to cancel out with milliliters of lake water on top. And then I have 0.4 micrograms. So I'm going to put 0.4 micrograms of mercury. So now milliliters of lake water cancel out. Now I have micrograms of mercury. Okay, so now, but I need kilograms. So if you know the exact relationship between micrograms and kilograms, then you can use that relationship. I don't know it. I'm sure you can figure it out. I'm not going to take the time to figure it out. But what I'm going to do is I'm going to go through the base unit as a middleman. So I always go through the base unit because for me that's easier to do, and it's a simple two-step process. So one of the things you need to know is you need to know the relationship between the base unit and the prefix unit. So here, the first one is micrograms and grams. So the way I set that up, and I'm going to erase this to make some room. So let's make some room here. That's good enough. So I set an equality and I put the base unit, in this case gram, equal to the other unit, which is microgram. And then what I do is I set it up by putting a 1 with the base unit. So I always put the 1 with the base unit. So I'm going to put a 1 with microgram, and then whatever I always put a 1 with the, not the base unit, but the prefix unit. And then with the base unit, I always put the prefix multiplier. So I need to know what micro is for multiplier. Micro is 1/1,000,000th of the base unit, or 10 to the negative 6. So I'm going to put 10 to the negative 6 here. And then I'm going to have to convert grams to kilograms. So I'm going to have to do the same thing. So I put an equality and I put kilograms on one side, and then I put grams on the other. And what I do is, again, I put a 1 with the prefix unit. So since kilogram is the prefix unit, I put a 1 with kilogram. And then the prefix multiplier goes here. So what's the prefix multiplier for kilo? Kilo is 1,000, or 10 to the 3. So I put 10 to the 3 here. So now I have my two relationships. So now I can use those to convert from micrograms to kilograms. So it's a two-step process. So I'm going to set this up. So my first is I'm going to convert micrograms to grams. So I'm going to use this relationship here. So micrograms goes on the bottom. So 1 microgram goes on the bottom, and 10 to the negative 6 grams goes on top. So 10 to the negative 6 grams goes on top. So, and this is mercury. Always write the substance, mercury. So micrograms of mercury cancel out. Now I have grams of mercury, so now I can use grams and kilograms to convert. So now I'm going to put grams on the bottom. So I have 10 to the third grams. So 10 to the third grams, or 1,000 grams of mercury on the bottom, and 1 kilogram of mercury on top. So 1 kilogram of mercury on top. So grams cancel out. Now I have my kilograms of mercury. That is what they want. How many kilograms of mercury? I am done. So now the only thing I need to do is calculate the answer. So let's calculate the answer. So here we go. So I have this many milliliters. So this number multiplied by, I'm going to multiply that by 0.4. And then I'm going to multiply that by 10 to the 6. So 10 to the 6. And then multiply that by 1, but that's not going to do anything. Okay, now I'm going to divide by the bottom. Divide by 1, divide by 1, divide by 1, divide by 1,000, 10 to 3. So divide that by 1,000 equals, And my final answer that I get is, oops, let me use my marker. So that's equal to, I have 631,301 kilograms of mercury. So that's our answer, but we're not done yet because the next thing is sig figs. We need to always check the sig figs. We need to write our answer in the proper number of sig figs. And remember that the number that we got here had one sig fig. So we have one sig fig here. We're only allowed that first sig fig. So we have one sig fig here. We have only one sig fig here because that 0 is not significant because it's a leading 0. It's a 0 at the beginning of the number. Those are never significant. So that's one sig fig. This is exact. This is exact. So we don't need to worry about those. So our answer can only have one sig fig. So that means that this 6 is the only one we're allowed. So we got to drop everything else. But we can't just drop it and leave a 6, right? We can't write 6 because 6 is not the answer. 6 is a lot different than 600,000, right? So everything we drop that is on this side of the decimal point, we need to replace with zeros because we need those placeholders. Okay, so 600,000 is the answer. And notice I'm not putting a decimal point there because if I put a decimal point there, that means the zeros would be significant and we don't want them significant. So we want only one significant figure. So you can leave it like this or write in the scientific notation. So this would be kilograms of mercury, or 6 times 10 to the fifth kilograms of mercury. And that would be the answer. I hope this was helpful. If you enjoyed watching this video, if you learned from it, please make sure you like the video, hit the like button, write a comment in the comment section, subscribe to the channel, and share it with other people. Thank you very much. I hope you enjoyed this and have a great day.